This is section 11.3, day 2. We're looking at standard normal distribution. We're going to look at the same type of bell-shaped curve, but this time we're going to look at values that are going to fall not right on a standard deviation, but somewhere in between. We're going to have a z-score. A z-score is going to help us determine a value that is in between the standard deviations. It's actually the number of standard deviations away from the mean. So your z-score is x minus x bar over sigma. And we're going to use that z-score to help us figure out how far the x lies above or below the mean value, x bar. Every time you use this standard table, it's giving you values that are less than or equal to the particular number that you're working with. These numbers in the table are all the percentages that are less than what you might be looking for. For example, if we're looking for a z-score of negative 2.34, we look on our table at negative 2.3, 4 is 0.0096. 0.0096. So they're saying that there's a 0.9% chance that a value is still going to be less than that. You can use standard normal distribution to find probabilities. Okay, for any normal distribution, by first converting values from the distribution to our z-scores using the formula we talked about earlier. We're going to look at example number 3. We're going to use the z-score and the standard normal table. The survey of a group of women found that the height of a woman is normally distributed by the mean height of 64.5 inches and a standard deviation of 2.5. So to find our z-score, which is our number minus the average over our standard deviation, our number is 58. We want to know what percentage of the women are below 58, or at least 58, or at most 58, minus the average divided by our standard deviation. When we do this, we get negative 6.5 divided by our 2.5, and that comes out to negative 2.6. 2.60, so we can come up to our table and we see negative 2.6. This would be 2.60, 2.61, 2.62. So we're looking for negative 2.60. So that's the 0.0047. We found the z-score. What does the z-score represent? Z-score represents how many standard deviations away from the mean a 58-inch tall woman is. We're going to use the normal table to estimate our probability. So what we're trying to find, the main question, is what's the probability that a person will be less than 58 inches tall. Well, the 58 didn't land right on our standard deviations. It happens to be negative 2.6 standard deviations down from the mean. So we're finding the probability that our z-score, find another score less than negative 2.6. They're equivalent to each other. So we go to the table, as we did before, and we look at the 0.0047. 0.0047. So we would call that a 0.47% if you had to write it as a percent. But when we talk about it as a probability, we like to leave it as a decimal. Okay, example number 4. A normal distribution has a mean of 20 and a standard deviation of 0.25. Use the standard normal table to find the probability that a value is going to be between 19.4 and 20.4. So if you look at your normal distribution, that gives you a hint that we're going to use the bell curve. We know that our average is here at 20. Our standard deviation is 0.25. So we're going to be at 20.25, 20.5. On this side, we'd be at 19.75, 19.5. We can see that our 19.4, which is a little bit further down, and our 20.4, which is a little short of that, is not landing right on our standard deviations. So we can't use the 13.5 and the 2.35 to help us figure out what our probabilities are. We've got to figure out our z-score for our 19.4 minus the average over a standard deviation. When we calculate out that number, we get negative 2.4. We'll figure out another z-score for our maximum amount. When we calculate that with the calculator, we get 1.6. Those are from our table. So what we're going to do, we're going to take our z-score of 1.6, we're 1.6 up from the average, and we're going to get a number from the table that's going to give us all the probability that a value is less than it. Then we're going to look at 2.4 below the average, 2.4 below it, and we'll look at our table to figure out how much falls below that. We'll separate the two, subtract the two, that is, to find out what values land just in between those. So, using your table that was given to you, a little bit more detailed table than what is in the book. We're going to look at 1.6. So you got to look on the positive side. 1.60 is 94.52. So the probability that we find an x value that is less than 20.4, that's the same thing as finding the probability of a z-score that is less than 1.6, which we said was 0.9452. Next, we're going to look at what's the probability of finding an x value that is less than 19.4. That's going to be the probability of a z-score that's less than 2.4. Well, we look on our table again. we look at negative 2.4 and we get 0.0082. So the probability that we land between 20.4 and 19.4 is the difference between our two findings. So we calculate that out, and using our calculator, we get 0.937. So it would be a 93% chance that you would pick a number between 20.4 and 19.4.